Welcome to the Pixel Maths Walking Talking Mock. This is the AQA Style Foundation Paper 1. Here is an incomplete pictogram. It shows the number of hours of sunshine on Monday, Tuesday, Wednesday, Thursday and Saturday of 1 week. We can see here the key shows us that one full circle represents 4 hours. So if we're asked to write down the number of hours of sunshine on Wednesday, looking at Wednesday here on our pictogram, we have 4, 4 and 4 full circles representing 12 hours of sunshine. We're then asked to look at Monday. Monday is here. We have 4 hours, 4 hours. Half a circle is half the time, so 2 hours. 4 plus 4 plus 2 gives us a total of 10 hours of sunshine. We then need to use this information in C and D to complete for Friday and Sunday. On Friday we have 8 hours, so that's 2 full circles, 4 and 4. And then on Sunday we have 6 hours. So 1 full circle for 4 and then half a circle here for the 2 hours. Here is part of a scale of a measuring jug. We can see here on the left-hand side millilitres and here fluid ounces. Using this scale, we need to find an estimate for 200 millilitres. So not the exact amount, but approximately how many fluid ounces. Well, 200 is here, and you can see it's almost in line with this. This line here must be representing 7 if we've got 6 and 8, halfway 7. Slightly above, but only a tiny bit. So possibly there an estimate, and a good estimate would be 7.05, just that little bit above 7. If you look at the mark scheme, the examiner will accept any answer between 7 and 7.5. So check that your estimate is somewhere between 7 and 7.5. We're then asked here to work in the opposite direction. We're given 4 fluid ounces. So 4 fluid ounces is this side. When we come across here, it doesn't match like this one as closely. So let's take a look. If this is 100 and this is 200, halfway is going to be 150. So here we need to estimate how far above 100. So a good estimate there, maybe 115, 110. We split this visually into 5 sections representing each 10. You can see there an estimate maybe 115 from what I can see. Again, the examiner accepts any answer between 100 and 120. So make sure your estimate is somewhere between 100 and 120. This table gives information about temperatures at 1 AM in 2 cities. In some cities on 2 days. We've got 2 days and several cities. We've got some negative numbers in here, so we're going to be looking at calculating differences and seeing which is the highest and lowest. Let's look at A. Write down the name of the city which had the lowest temperature on Monday. So we're looking for Monday, so we're in this column here. All the way down here, we're looking for the lowest. So if this is our thermometer, that's 0. And down this way we've got negative, and up here positive, -1, -2, etc. The lowest value is going to be the most negative. And in that case we have -11. So the city, that's wrong. Okay, I'll start the thing. So when I say we're looking for the lowest number. So here we have -12. Which corresponds with Leeds. So this is the city with the lowest temperature on Monday. We now need to work out the difference in temperature between Newcastle and London on Monday. So let's take a look. Newcastle is -11 and London here is -7. So how many degrees between -11 and -7? So we go up, -10, -9, -8, -7. So there are 1, 2, 3, 4 degrees difference between the temperature in Newcastle and London on Monday. Now I need to work out the increase in temperatures in Toronto between 1 AM on Monday and 1 AM on Tuesday. So this time we're just looking here and at these two values, -2 and 5. So from -2, we go to -1, 0, 1, 2, 3, 4, 5. Counting along, 1, 2, 3, 4, 5, 6, 7. So the increase in temperature there is 7 degrees. We're told that Gareth lives in Cardiff. So if we're looking here for Cardiff, we'll be focusing in on this part here. We're told that at 1 AM on Monday, when it's -6, at 1 AM, he predicts that the temperature in Cardiff is going to rise by 2 degrees every hour. So at 2 AM, it will be -4, be higher. It will then go to -2 at 3 AM. And that's what the question's asking you. Work out the time at which the temperature will rise to -2, -2 here. So that will be 2 hours after 1 AM. So the time will be 3 AM. This table shows part of a bus timetable. We can see here that the bus leaves Shotton at 7:30. That's here. And we're asked what time it arrives in Alton. The arrival time in Alton, reading down the table, is 8:30. Another bus leaves Purhole at 8:28. That's this bus here, looking across. And we're asked how many minutes should it take to get to Hexham. So it arrives at Hexham at 8:45. So from 8:28, we add 2 minutes on, we'll be at 8:30. From 8:30 to 8:45, we add 15 minutes. So altogether, it will take 17 minutes. Serena lives in Crook, which is along here, we can see. Change the pen. And she has to be in Hexham for 11:15, so that's 11:15. Look down at Hexham and we're asking for the latest bus to arrive in Hexham by 11:15. So this bus is too late. This bus would be the last bus she could get, the latest bus to arrive here before 11:15, 11:15. What time would she therefore have to leave? She would need to get the bus at 10:15. Here we have a menu for Jessie's Cafe. Lisa buys a pizza and a coffee. What is the total price? So one pizza, £2.35, one coffee, 80 pence. Let's put that into pounds so that we add up in the same way, 0.80. Total price, when we're adding these up, remember we don't have a calculator, we've got to keep our decimal points in line. 5 plus 0, 5, 3 plus 8, 11, 1 here, carry a 1, 1 and 2, 3. Total price for part A, £3.15. Moving on to Deborah now. Deborah buys 2 burgers and 2 teas. So we want 2 of the burgers and 2 of the teas. So £1.70 times 2. So her 2 burgers, 7 plus 7, 14, £3.40 for the burgers. The tea, again converting to pounds, 0.65. 5 plus 5, 10, 6 plus 6, 12, add here 13, £1.30. Total price, £3.40 plus £1.30, £4.70. So the total cost for Deborah's 2 burgers, 2 cups of tea, £4.70. Now moving to part C. Michelle has £10. She wants to buy as many sandwiches as possible. We need to work out how many sandwiches. So her maximum she has is £10. They're £1.30 each. So let's see how many she can get. Well, we know she can definitely get 2. 2 sandwiches are going to cost £2.60. So for 2 sandwiches, £2.60. What about for 4 sandwiches? Doubling that. £2.60 plus £2.60. 12 will be £5.20. Okay. What about for 6? 6, she's got her price for 4 plus another 2. So for 6, we have £7.80. Okay, can we fit another one in for 7? Let's try another £1.30. 8 plus our 3 is 11. Carry 1, £9.10. So this is for 7 sandwiches. She's got here now 90p change, not enough to buy another sandwich for £1.30. So her maximum number of sandwiches she can buy is 7 sandwiches. Write down the coordinates of point P. X, then Y. P, X, 4, Y, 7. Coordinates of P, 4, 7. The coordinates of Q, X first, 0. Y, 3. We're then asked to find the midpoint. There's 2 ways you can find the midpoint. First, we can add up the 2 values here. So adding up our y coordinate, we get 10. Adding up our x coordinate here, we have 4. That's the wrong number. Okay, start this question again from the beginning of the coordinates. When I say 4 about P. So the coordinates for point P go across x, 4, and go up to y, which is 6. Coordinates 4, 6 for point P. Moving on to point Q, x is 0, y is 3. Then we're asked to find the midpoint of this line. There's 2 ways we can do this. First, we can add up our y coordinates, 9, our x coordinates, 4, and divide by 2, half, to find our midpoint, our halfway point. 2, half of 9, 4.5. Another way you can do it is by looking at the line, and you can see here is the midway point, halfway along. So our coordinate here is 2, and our coordinate here is halfway, 4.5. Again, using our values here, adding them up, dividing by 2, or again, looking at your graph. Here are some fractions. Which one of these fractions is not equal to a half? We need to give our answer, a reason for our answer. We can see here that 7 is half of 14. That's definitely a half. Here, we can see 2 is half of 4. We can see here that 4 is half of 8. But here, 2 is not half of 5. 2 is half of 4. Other way round, if we look at the doubling, we can see here that this, if this was this value here, we cannot divide this and get a half. It doesn't cancel. This fraction doesn't cancel. So which fraction is not equal? 2 over 5, explaining that 2 is not half of 5. Now I need to work out 3/4 of 20. You might want to think about 20 as a whole like this and cut it into quarters. So if we were to split 20 into 4 equal sections, we would have 5, 5, 5 and 5. 20 divided by 4 gives you 5. Now we want 3/4, so we want 1, 2, 3. 3 times our 5 to give us 15. 3/4 of 20 is 15. We're told that D equals 6 and asked to find the value of 3 plus D. 6 gives us 9. The value of 2D, 2 and D. This means 2 times D. When a letter and a number here, our number 2, our letter D, is pushed together, we don't write the multiplication in, but this is what it means. So we're going to have 2 times D, which is 6, which gives us 12. Okay, now we have a new expression equation here with 2 parts, 2 terms, 3f and 4g. The value for f is 2, positive. The value for g is negative 1. Okay, let's substitute this in. 3f means 3 times f plus 4g, 4 times g. Remembering for bid maths, we're going to do our multiplications here and here first, then add last. So we have 3 times 2, f is 2, plus 4 times negative 1. 3 times 2 is 6, add 4 times negative 1 is negative 4. And here now we have 2 signs together, one positive, one negative. Therefore our sign is negative. 6 take away 4 leaves us with 2. So the value for H is 2. James has 9 cards. Each card has a shape drawn on it. Each shape is a circle or a square or a triangle. We see here that altogether there are 9 cards in total. From circles we have 1, 2, 3. For squares, 1, 2, 3, 4, 5. And we have 1 triangle. Our first question is, which shape is most likely to be on the card? If James takes a card at random, which shape is most likely? What shape is the most popular, the most common? You can see here a square. There are 5 squares, which is more than the circles and the triangle. What is the probability that James takes a card that has a square on it? Well, there are 5 squares out of a total of 9. The probability is 5 over 9. Alan recorded the number of text messages sent by 7 people one day. Here we have a list of numbers. The first step is to put these numbers into order, starting from the smallest. So we have 4, 6, 6, 8, 9, 12 and 15. First we're asked to identify the mode. This is the number that's the most popular, the most common number. Which number appears the most? Well, we can see here that 6 appears twice and all other numbers only appear once. Therefore 6 is the mode. The range is the biggest number, which in our case 15. Subtract the smallest number, which is here 4. 15 subtract 4 gives us our range of 11. We then need to find the median. The median is the number in the middle when the numbers are in order. So we can find the middle number by crossing off our smallest and our biggest, our next smallest, our next biggest, our next smallest, our next biggest. And we can see here that 8 is in the middle. Therefore 8 is our median. This diagram is about bearings. We're first asked to measure the bearing of B from A. Really key part here, from A. That means we're starting at A. From A, north line, clockwise, around to this point here. So taking your protractor, sharp point, the point right here in the middle on A, turning round your compass to line your 0 with your north line. So 2 points here, right in the middle, this north line matched up here with 0. Now going around the edge here, 0, 10, 20, 30, 40, 50, just on there, just before 60, coming out here at 59 on my diagram. So I'm going to use that in a moment. So the bearing here is 59. However, we must quote our bearing as 3 digits. So 0, 5, 9, 0. Really important that 0 there in the front. You are not going to get the mark otherwise. If you check on the exam paper for that one, the examiner will accept any answer between 0, 5, 7 and 0, 6, 2. So just make sure that your bearing that you measured is somewhere between 0, 5, 7 and 0, 6, 2. We're then told that another mast C is on a different bearing, 160, from B. That means we're starting now at B. So we're going to mark up here, sharp point here, the centre point here in the middle, north line marked with 0, going all the way around in clockwise direction to 160. Make a little mark, take it away, and we're told here that this is 4 centimetres from B. So using your ruler, putting your 0 on B, turning your ruler around, take this, oh, that's my scale changing, turn this, there, oh, other way. I need to line that up again. Right, let me turn it here. Oh, that's now moving. Turn it up here, there we go. Okay, so I'm going to line this up with my marking, but I'm only going to go to 4 centimetres. Again, here I'm in millimetres, so the point is here. Mark, come away. I've got to mark this point with an X. So here is point C. Bearing 160, 4 centimetres away from B. So 2 parts there to that last part of this question. Work out the size of the angle marked P. This is a straight line. Angles on a straight line add up to 180 degrees. 180, subtract 124, gives us 56. Angle P is equal to 56. Work out the size of angle Q. Here we have a right angle, 90 degrees. Subtract 68. Leaves us with 22. Our angle missing here is 22 degrees. Here are 6 temperature time graphs. We need to match these graphs here with the description on the right-hand side. So let's read the first one. The temperature stays the same for a time and then falls. So we're looking at our graphs here. Stays the same must be here and then going down. So the graph that stays the same and then goes down is graph D. Our next one, the temperature rises and then falls very quickly. So we're looking at one going up, then falling. That stays the same. This goes up, stays the same, up. This one goes up, then falls. So this describes graph C. We then have the temperature always stays the same, so it doesn't change. This here is the A, just stays constant. The temperature rises, stays the same, then falls. Rises, stays the same, then falls. Graph F. Lastly, this must be E. Let's read it though. The temperature rises, that's up, stays the same, and rises again. So this correctly matches here with the description. Rises, stays the same, rises. This table gives the height and length of two more sheep, shown here for our scatter diagram. We need to plot this information onto the graph. So first off, we have 65. I can see this on the axis here on the X, and a length of 100. Here is 100. So coordinate plotted there. Then we have a height of 80 and a length of 110 here. We're asked to describe the relation between the height and the length of these sheep. We can see here as the height increases, the length increases. So this is a positive correlation. We're then given the height of a sheep to be 76. The height, 76 here. And asked to estimate the length for this sheep. First, we must take our ruler and draw a line of best fit. So a line that goes through the middle of the points and has approximately the same number of points above as below the line. You can see here we have most of the points on, 2 below and 2 above. So taking your ruler again, going down to 76, not just using your finger, coming up here and a cross. So the value here we can say almost 110. So we're going from 100 to 110 in 5 spaces. This will be 102, 104, 106, 108, a little bit above, perhaps there 109 centimetres. Now the answer will depend on where you have drawn your line. In the exam, an examiner will allow any answer between 105 and 110. So just check your answer is somewhere between 105 and 110. Amy buys 50 computers. She pays 160 for each, but then she's going to sell some. Notice the bold. She wants to sell to get at least 35% more than she paid for all of the computers at the beginning, and she's going to sell each computer for £400. We need to work out the smallest number of computers Amy needs to sell. So there are a number of steps to solve this problem. Our first step is to work out the total price. How much did Amy pay for the computers at the beginning? So 50 multiplied by 160. 5 times 16 is equal to 80, 0, 0, 0, 0. So at the start, before we talk about the selling, we need to multiply these two values together to see the total price that Amy paid. Next, we need to find the 35% of the 8,000 because she wants to get more, at least 35% more. So we're going to find out the 35% and then add it to the price at the beginning. So of this, our 100% is equal to the total amount, 8,000. Therefore, 10% is equal to 800. We can then find 5%, half of that, 400. So if I'm looking for 35%, remember I haven't got a calculator, I'll take 3 of those and 1 of those. 3 times 10, 30, plus 1, 35. So 3 times 8 is 24. Add a 0 and another 0. 1 times 4, 400. Total, 2,800. So 35% of 8,000 is 2,800. So the total amount that Amy wants, the price, she needs to get is 8,000, what she originally paid, plus at least 35% more, 35% here, means 10,800. So our next step is to find out how many computers. So each computer she is selling for 4,000. Okay, so what if she sold 10 computers? She'd have 4,000, sorry, each computer she's selling for 400. So if we times by 10, we have 4,000. So 4,000 for 10. Okay, still not enough. What about another 10? Another 4,000. Total then, 8,000 she's made. Okay, what about another 5? Let's get half of that amount. So another 5 will give us another 2,000. Add another 2,000 here. We've got 10,000. So we're almost there. We need another 800. Each of them are selling for 400. So if we take another 2, that will give us the 800 we need to here to make the 10,800. So how many computers altogether here from our calculation? 10 plus 10 plus 5 plus 2 gives us 27 computers needing to be sold for Amy to make at least 35% more than what she paid for all of the computers. Sidra and Gemma share £48 in the ratio 5 to 3. Work out how much more money Sidra gets than Gemma. So let's have a look. Sidra and Gemma. 5 to 3. Total. 5 plus 3, 8 parts. Total amount, 48 divided by 8, £6 for each part. So here we times by 6 and here we times by 6. Sidra gets 30, Gemma gets 18. The question wants to know how much more, what's the difference? So this is what Gemma gets. Sidra gets £12 more than Gemma. So the answer is £12 more. Here we have an isosceles triangle. We can see here and here are our two lengths that are the same. If this is an isosceles triangle and these two sides are the same, this angle and this angle, the two base triangles, angles are equal in the triangle. So when asked to explain why this angle equals this angle, we need to state that isosceles, the two base angles are equal. Now we need to solve. We need to find the value of x. Let's put all the x's on the side we have the most. Here we have 3x. So let's subtract our x from this side, which leaves us with 30. We must also subtract an x from the left-hand side, leaving us with 2x minus 10. Now this side, we want the x's only. So let's remove the 10. For negative 10, we must do the opposite, add 10. That makes it disappear, but we must also add 10 to the other side. So here we're left with 2x equals 40. Added our 10 to the right-hand side. Now we don't want to know what 2x is, we want to know what 1x is. So we are going to divide by 2. 40 divided by 2, half of 40 is 20. Here we have a triangular prism and we're asked to find the volume. Our first step is to find the area of the cross section, which in this case is the triangle. We need to take the height, 3, multiplied by the base, divide by 2. Height times base divided by 2 gives us the area of the triangle. 3 times 4 divided by 2. 3 times 4 is 12, divided by 2 is 6 centimetres squared. That's the area here of our cross section. We then need to multiply by the length, the 20. So 6 multiplied by 20 gives us our volume of 120 centimetres cubed to the power 3 there. Here we have a plan and front elevation of a solid shape. On the grid, we're asked to draw the side elevation of the shape. So we can see here, using our plan and front elevation, that this shape is just a square like this. And we look here at the side elevation of the shape. We look here at the front again, we can use this to draw a sketch of the solid shape. We have a trapezium at the front. And a trapezium prism back. So here, the important part is a trapezium at the beginning and then 3 lines going backwards to make it 3-dimensional. Here we have 2 brackets. First we must expand and then simplify. 3 times x is 3x. 3 times 5 is 15. Moving on now to our second bracket. 2 times 5x is 10x. 2 times negative 6 is negative 12. Be careful here now of the negative when we simplify. So let's take a look at our x's first. We have 3x here plus 10x here. Altogether, we have 13x. Moving on now to our numbers, positive 15 subtract 12 leaves us with 3. Now in our next 2 questions we need to factorise. That means we need to insert the brackets. We're looking for what's common in both of them. You can see here we have the number 5 and 10. The highest common factor of 5 and 10 is 5. Therefore 5 goes outside the bracket. Inside the brackets, 5 times x makes 5x and 5 times 2 makes 10. Looking here now, the numbers, we'd only have our coefficient here of 1 and 7. So we're looking at the x's that appear in both. Therefore the x goes outside the bracket. X times x makes x squared. X times negative 7 makes negative 7x.